is to help you to work on the time value of money problems, including annuity and bond pricing. So basically, there are three formulas that I want you to learn. The first is that according to this timeline, the cash flows are denoted like this. So you have three variables, right? PV, cash flow C, and the interest rate R, right? So if you line up all these cash flows well, it's very easy to apply the formulas here. For example, if you don't know C, then you can use the function PMT, stand for payment, to figure out what is that periodic payment C is. So for example, if you are trying to buy an annuity, spending some money on an annuity, and you know the interest rate, you know the terms, how many years, then you can calculate the monthly payment with that PMT function. Or in case number two, if you don't know the price, the present value of this stream of payment, like a bond, right? For bonds, you know the coupons, you know the numbers of periods, you know the yield to maturity, which is R here. Then you can figure out the value easily through this NPV function. Or one other possibility is that you know the coupon, you know the price, but you don't know the discount rate, which is the yield to maturity in bond pricing. So you can use the function IRR to figure that out. So here I'm going to show you how to work on these three examples. So let's start with the first annuity one. So in this calculation, you are trying to figure out, given this amount of initial investment, $100,000, and you know the rate of return is 5%, and you know it's going to last for 20 years, which is 20 times 12, that's 240 months, right? So you want to figure out C. So the formula to apply that is very simple, using PMT, and the interest rate is 5%, but this is annual, so you need to be careful. You need to divide it by 12 to get the periodical rate, because now we are working on monthly, right? And T is the period, so we are talking about 20 years, but again, you need to make it into monthly, so multiply by 12 to get how many months you have in the calculation. And lastly, you need to enter the value, initial value put in there. Be careful that this PV it should be negative, because you put the money down, so that's a cash outflow, and then you receive all these cash inflows, so you're gonna do minus 100,000. Okay, so this is what you get in the monthly payments. And let's see, and I think I have too many zeros, so this is 1 million, now 100,000. So this kill one. So if you buy an annuity with an initial investment of $100,000, you can expect to get $659, almost $660 back per month, right? So that's the first application. Now let's look at the second application. We want to price a bond, and we sort of know the coupon payment, those cash flows, and we also know the yield to maturity. So what we can do is we're gonna set up those timeline well. So we need to start with the cash flows, right? So I want to do 20 years, but remember, when we're doing 20 years bond, you pay semi-annually, so you should get 40 in payments. Okay, so that's what we have. And what about a coupon payment? Well, coupon payment, according to the convention, is $1,000 times the coupon rate 5%, but make sure you divide by 2 to get a semi-annual payment. So every 6 months you receive $25. So I'm gonna replicate the whole thing down all the way down here. But at the very end, you need to include that principal payback, which is the par value. So now I set up my timeline and all the cash flow will. I can apply the formula now. So let me use NPV for that, and now I need to enter R. So for R here, it is a yield to maturity 3%. But remember, 3% is annual rate, and whenever we are doing this discounting, we are looking at 6 months for each period, so that's half of 3%. So you need to divide by 2 to get that. And the next input here is simply the cash flow. So let's just select all these cash flows. So we get a bond price which is over $1,000, and because yield is only 3%, coupon is paying you 5%, so it sells higher than the par value. So that's understandable. Now I turn the same question around. We know the coupon rate, same coupon rate, but we don't know the yield to maturity now. So now we need to do these yield to maturity. So we know the price. So price is $9.90. So I'm gonna put the price here, and there's a trick that you need to a pitfall you need to pay attention to. The first is the initial cash outflow. Suppose you buy the bond paying this much. Right, so you need to enter it as the first cash flow in negative term. So now I can use the IRR for that calculation. So if I just select the whole cash flow, including the very first one, which is the bond payment, bond price, then you get the discount rate. And this is actually the semi-annual rate. So for the annual rate, you should multiply by 2. So for annual rate, it will be 3% times 2. Right, so it's actually not 3%, a little bit less than 3% if I pull that up. So you see that the coupon rate is 5%, and the yield to maturity is actually slightly higher, 5.08%. That's why the bond is selling less than par, right? So that's understandable. So that's also a check to your answer to see if you're correct. So I hope this video helps.